Then this is called the load cycle. For fatigue analysis, we have to perform these load cycles. How we can define it? Let me give you the example. Load case cycle, here we have to define the number of cycles, which is given in the formula that we have discussed and studied in part 2. That is SA is equal to F into 1.25 times SC plus 0.25 times SH, where SA is the allowable expansion stress range and SC is the basic allowable stress at minimum metal temperature, and SH is the basic allowable stress at maximum metal temperature. So all these SC and SH values, it's available in table 1A of the code, B31.3 as B31.3, and factor F, which is called the stress range reduction factor for displacement cycles, mean condition for the total number of cycles over the expected design life. This F has a value of 1 for a situation where the total number of cycles is 7,000 or less. Then we can take F as 1. It means that 1 cycle per day for nearly 20 years. I mean, if the design life of the plant is 20 years, then we can consider F is equal to 1, which is a common design parameter. But if the design life is more than that, then we have to further use the number of cycles as per the table given in ASME section A division 2 pressure vessel code. And there if you'll go, you will find that equal to 7,000 or less than 7,000, factor F is 1. Over 7,000 to 14,000, this factor will be 0.9, and over 14,000 to 22,000, it is 0.8, and 22,000 to 45,000, 0.7, 45,000 to 100,000, it's 0.6, and so on. So that table is given over there. So based on that, we have to define it over here, the number of cycles. Then after that, this icon is given that if you have like used one load cases in one of the previous job, and you don't want to build it again and again, you don't want to waste your time, so you can simply click over here and import those load cases over here in this job or in this project and simply use it. After building the load cases, what we have to do, we have to execute the static analysis. And in the static analysis, what we have to do, we have to click over here in this double run. This is called the double run. It will perform the analysis. It's what it's written one by one. We will check. See, equation, it will solve the number of equations. This much number of equation it has solved. Band width is 48. Current number of cases is 6. Total cases is 35 with the combination. Iteration is 12 for the non-linear. Okay. This is the time taken that to solve all these things. And this is the decomposition for those matrices. Then here F2 option, the single step through restraint of. F3 is change friction tolerances, and F4 is print restraint status. So number of non-linear restraints is 58. Non-linear mean where we have defined the friction or we have given the gaps. So those are the non-linear restraints, and these are the numbers. Then solution core use percentage 1, non-linear restraints changes, non-convergence last iteration is 2. So it will perform the iteration and it will converge. If it will not converge, it will continue and it will show the error. So review output report. So after that, when you will run the analysis, this window will appear at the end. When this window will appear, it means there is no red sign. It means your all stresses, everything is fine. What you have to do, you just have to see the forces and moments at the restraint location or at the nozzle piping, between the piping and the equipment. I mean, nozzle evaluation you have to check, and at the restraint locations you have to check the loads. So stresses are pass. It means there is no red sign, all the stresses are fine. So how to check the report over here? So we'll see these two windows. What you can do, simply click over here. For example, I will click on hydro plus T1, T2, T3 and WS, and then I will click over here the restraint summary, and then I can add it and it will come over here in the output report. Or I can click over here, I can view it directly from here. So these icons are same. This icon is input icon. This icon is for the dynamic. It will show you the dynamic movement of the 3D model, and all these rest of the icons are same as before. And further, when you will select it, it will show you like this. So I have selected the stresses for these cases and restraints for these cases. Like normally what we do, we check the stresses in hydro. We check the stresses in sustained cases, then we check the stresses in expansion cases, right? We don't check the stresses for operating cases. So what we do, we check, normally we are checking the restraint summary or the nozzle loads or the displacement and forces and moments on design temperature, operating and design minimum temperatures. And after that, in these three icons, by clicking these icons, you can view the report, you can export in Word, you can export in Excel as well. So when you will click on the finish button, it will export it. It will display the, if you click over here, it will display the results, and if you want to export, then it will export it. And if you want to print it, add, remove, you can add here, further you can remove here, you can clear all of these. So these are those things. And here if you click on the finish, even you can make it up and down as well, like you want this one first, this one second, like that you can move it with up and down. You can click over here, it will finish it and it will generate the report, final report that you are issuing to the client for review. So if you click, the output result will be in this form. See the occasional expansion cases. So it is saying the code compliance evaluation passed. This is the percentage, 98.3% at this node in this load case. This is the maximum expansion case, so it's a 98% here. All these details you can see in the output report. It will give you the code stress, axial stress, bending stress, torsional stress, hoop stress, and then the intensity 3D maximum intensity. So here is the ratio of the maximum load case and this stress. And here you can see the allowable stress value. Against that, this percentage is there. And axial stress, this is the maximum at this node in this load case. Then bending stress is this much at this node, and this is load case expansion. Torsional stress this much at this node, and this is load case. So this way you can understand, and these are the node, 10 node, 20 node, these are the cases, hydro, sustained, and here is the code allowable values. Similarly, in the restraint summary, when you select the hydro plus operating, so it will show you the restraint summary forces Fx, Fy, Fz, Mx, My, Mz, dx is the displacement in x direction, dy displacement in y direction and z direction, and x, y and z is as per the coordinates shown in the 3D model of the Caesar software. So at node 10 we have defined for example is anchor. So at the anchor location maybe there is some equipment connected, so we consider equipment connection as anchor so that we can get the maximum forces and moments over there. So these are the forces and moments, and you can qualify these forces and moments as per the based on the allowable values that you receive from the vendor of that particular equipment. And these are the displacement values. When we'll perform the stress analysis, actual stress analysis, then we'll go through each and every item of the output report and output results, and how to interpret those results in practical or as per the layout. What is the impact on the output results, and how we will change in the input that has impact on the output results, how to control the forces and moments, how to control the stresses. All these things we'll discuss when we'll perform the actual stress analysis in Caesar software. So at the end, along with the report, we have to generate the isometric generation, that is called the isogen. It's a new module, and you can simply click it and it will generate the isometrics from the Caesar software itself. So it is automatically it's generating these isometric, and based on this isometric it is defined. When you can have multiple options here, that you can split it into number of sheets, you can control the number of sheets, you can split it the node wise. So it is based on your own customized way. I mean, if you want to control it, the total number of sheets, you can do it. So it will give you the complete detail based on the stress nodes, node 10, node 20, node 30, how it is defined in the Caesar software or the input. So it's showing the same way in the output or in the isogen. After generating the isometrics, you can attach these isometrics along with the stress output reports, input summary, output reports, and isogen. These are three parts of the stress report, and then after that you can issue it to the client. Further sources for detailed learning, you can go to the help, and in help you can find online documentation where you can find the user manual for the Caesar, application guide, technical reference manual is there, where a lot of technical discussions and technical examples are given over there. Quick reference guide is there, isogen export, how it works, and how to build the txt file. All these information are there in the user manual and the respective manuals in the help tab. So thank you very much, and see you in part 4 when we will perform the actual stress analysis in the Caesar software itself. Thank you.